In this session, we are going to talk about basic arithmetic operations. First of all, we can discuss how to add numbers. Adding numbers. So you know you can add any number. 1 plus 1 is 2. So this is the first place. And then say for example, if I want to add 20 plus 30. So this is the first position and this is the tens position. So this number is 20 and 30. So 0 plus 0 is 0 and 2 plus 3 is 5. So another example, 1523 plus, so if I want to add with, so 523, so I can write this number as like this. So 1523 I can write here, and then starting from this, the first position, and then 3 here, 2 here, and then 5 here. And then you can add 0 here. So it doesn't have any value on that. So keep the 0 here and then add these two numbers first. And 3 plus 3 is 6. 2 plus 2 is 4. And 5 plus 5 is 10. We put 0 in here and then 1 goes to the other side. And 1 plus 1 is 2. So the answer is 2046. Right. Now we're going to discuss about a little bit of adding decimals. So for example, 76.820, say like this. Okay. And then, yeah, so do like this. Say 0.52 plus 0.73. So if you want to add those two numbers, you write down 0.52 here and then 0.73. And then add first this side. 2 plus 3 is 5. And 5 plus 7 is 12. And 2 here, 1 goes to the other side and 1 here. Say, for example, this way. So if you want to add 76.82 plus and then 25.325. So first of all, we need to write down this number first. 25.325. So remember, always we call digit by digit after decimal points. So 25 point, we don't say 325, we say 325. So plus 76.82. To make it equal, you can add as many zeros as you want. So doesn't have any value on that. So keep 0 here to make it equal. So 5 plus 0 is 5. 2 plus 2 is 4. And 3 plus 8 is 11. We put 11 here, 1. And then 1 goes to the other side. 5 plus 1 is 6. 6 plus 6 is 12. You put 2 in here. And then 1 goes to the other side. 2 plus 1 is 3. 3 plus 7 is 10. So answer is this. Right. So I hope that you understood adding numbers. And then we go with that subtracting numbers, subtraction. So how to subtract? So you know that 1 take away 1 is 0, right? And then any number, you can say 25 take away 9. So you say 25 right down here, 9 here, you put 0 at front to make it equal. Doesn't have any value on that. And then 5 take away 9, you can do this. And then you take 1 from the other side and this becomes 15. And then 15 take away 9 is 6. So here become 1. And then 1 take away 0 is 1. Again, one more example. 100 take away 73. So write 100 here, take away 73 here, and 0 take away 3. You can't do that. So you take 1 here, and here it become 10. And then you take 1 again here, and this become 10 now. And 10 take away 3 is 7. And now here is 9. So 9 take away 7 is 2. And then here become 0. So answer is 27. And we go with that decimals and say, for example, if I want to take off 23.5, take away 16.27. So in this case, write down 23.5 here, and then on the bottom, and then you can write down 16.27. So to make it equal, you put 0. That's fine, and doesn't have any value on that. And then 0 take away 7, you can't do it. Take 1 from here, and here become 10, and then 10 take away 7 is 3. Here is 4. 4 take away 2 is 2. And then 3 take away 6, you can't do that. And then take 1 from here. 13 take away 6 is 7. And 1 take away 1 is 0. The answer is 7.23. See, any number 1 times 1 is 0. And then any number, say whatever, say 100. Say 100. Any number multiplied with 0, the answer is 0. I'm sorry here. So this is 1. This is 1. Any 1 times 1 is 1. And then any number multiplied with 0, answer is 0. Any number, say for example, flower multiplied with 0, the answer is 0. Right? And then I can show you how to multiply two numbers. And 25, say 25, you need to multiply with 3. So you can write down like this, 25 and 3. And 3 times 5 is 15. 5 here. And then 1 remaining. 3 times 2 is 6, plus 1 is 7. So answer is 75. Right? And then again, so 523 times, if I want to multiply with number 50, if you want to multiply, and then what you have to do, write down this number 523 here and multiply 15. And then here you multiply 5 times 3, 15, 5 here, 1 remaining. 5 times 2, 10, and then plus 1 is 11, and then put 1 here, then again 1 remaining. 5 times 5, 25, plus 1 is 26. And 1 times 3 is 3. 1 times, see now I write this 3 right below this number 1. So you have to shift to the left 1 digit. So you're starting from here, right below this number, and 1 times 3 is 3 here, and 1 times 2, 2, and 1 times 5, and 5. See now we need to add. So you can add, put 0 in here, doesn't have any value on that. 5 plus 0 is 5, and 1 plus 3 is 4. 6 plus 2 is 8. 5 plus 2 is 7. So this is the number. This is the answer. Now again, so any number you multiply with, any number you multiply with 10, 100, 1,000, whatever that, 10,000, 100,000, whatever. So you need to add 0 at the end. For example, 73, if you want to multiply with 1,000, what you have to do is write down this base number. This is the number. and then you add 1, 2, 3 zeros at the end. So this is 7300. So these three number, 3 zeros goes on here. Again, 65, if you want to multiply with 100,000, so 100,000, then what you have to do, write down this number, 65, then 1, 2, 3, 4, 5 at the end. 1, 2, 3, 4, 5 dot. After that, you can put as many zeros as you want. Here also the same. Doesn't have any value on that. Got it? And I give you a simple trick. And then if you want to multiply any number with 11, for example, 63, if you want to multiply with number 11, and then what you have to do, you have to write this number here and then add those two numbers. 6 plus 3 is 9, and then 6 you can put it here. So answer is 693. Again, so 95, if you want to multiply with number 11, and then keep 5 here, and then 5 plus 9 is 40, and then 4 here, and 1 goes to other side, and 9 plus 1 is 10. Again, 2015 times number 11, keep 5 here, 1 plus 5, 6, 0 plus 1, 1, 2 plus 0, 2, and then keep this 2 here. The answer is this. Right? I hope you understood this. And then now go to decimals, and then any number you multiply with decimals, for example, 0.05, 67, you need to multiply with 10,000. See how what you have to do? You have to write this number without decimal points, 0, 5, 6, 7. So actually you keep the finger here and the dot is here, right? And then always remember this is 10,000. How many zeros we have here is 1, 2, 3, 4 zeros. And in the multiplication, we have to send our finger to the right side. So 1, 2, 3, 4 dot. And then after that, you can add many zeros as you want. Right? The answer is 567. Now again, 0.035, if you want to multiply with 100, what you have to do, just write the number 035 without decimal point, and then you keep the finger here. So you need to send your finger to the right. Multiplication is right, and then how many times is 2 times. So 1, 2, so dot here. So 3.5. Right, again one more example, 0.0678 times 100,000. Right, write the number 678, 1, 2, 3, 4, 5 times to the right, and 0 here, and then 1, 2, 3, 4, 5 we don't have, keep 0 here, and dot after that, as many zeros as you want. Right? Got it. Now we go to the next one. Now for example, if you want to add multiply 2.3 into 0.06, so what you have to do, you multiply without decimal. So 23 you write here, and then 6 here, and then multiply. 6 times 3 is 18. You put 8 here, 1 remain. And 6 times 2 is 12. and then 1 is 30. So you keep 138, and then how many decimal points we have altogether? 1, 2, and 3. So always remember the integer number that we have, that in the end we have that the dot, right? And we have to send our finger to the left side altogether. 1, 2, 3 points to the left. 1, 2, 3 dot, and then we can add many zeros as you want. So answer is 0.138. Right? Okay, so now we are going to talk about division. So division, so like this. So any number, so 3 divided by 2. So we can divide how many 2's. So we call first, so how many 2's goes inside number 3 is 1. 2 times 1 is 2, and 3 take away 2 is 1. So we'll see that. So what is this number? So actually this number is dividend. And this is divisor. We call divisor. And this one we call quotient. Quotient. And this one is remainder. All right. So here, now look at that. So if you want to divide 35 divided by 3, and then you need to find how many 3's goes inside. 3 is 1. 3 times 1 is 3. 3 take away 3 is 0. And check 5 down. And then how many 3's goes inside number 5? Which is, you get 1, 3. 3 times 1 is 3. So 5 take away 3 is 2. Say if you want to make it decimal, you add 0 in here and then put the point here. So how many 3's goes inside? 20 is 6. 3 times 6 is 18. And 0 take away 8, you can't do. Add 1 here. 10 take away 8 is 2. Take 0, and then but you're not putting dot again. So just how many 3's goes inside? 20 is 6, 18, and then 2 again. So this is continuous like this. So answer is 11.66 is continuous like this. Okay. Okay, so now I'm going to discuss about that, how to divide numbers from 10, 1,000, 10, 100, 1,000, 10,000, so on. So for example, if you want to divide number 30 divided by 10, so what you have to do, write 30 here. Always remember your decimal point is in the end of the number, integer number, and then but you can't see that, but it's in there in the end on your right. And then division means you have to send your hand to the left side. How many times? 1. Why? Because only 1 0. And to the left means 1. This answer is 30. Again, so 5,674 divided by 1,000. Look at that. Write the number here, 5,674 and to the left 1, 2, 3 points. 1, 2, 3 dot. Right, and then again 5.678 divided by 1000. How to do that? Write this number 5678. This one, how many times we have to send it to the left? 3 times. Right, and then here is the dot, previous place, and then 1, 2, 3 dot, and you can add many zeros as you want. Right, that's it. And then I hope that you understood this lesson, and then we can continue from next one. Thank you. In this session, I am going to talk about the real number system. The system of real numbers consists of a collection of smaller sets of numbers that has evolved over several centuries. It began with numbers used to count objects, which were used for trading. It was then extended and refined as a need for numbers to represent parts of objects, and locations on the number line became important. Below is a discussion of the sets of numbers that make up the real number system. Each of these sets builds on those contained in the preceding sets. First of all, I'm going to talk about natural numbers. So, natural numbers can be thought of for counting numbers. So, for example, counting numbers we can write like this. We say that the set of counting numbers C, and then we never count from 0. We count, the counting start from number 1. So 1, 2, 3, 4, so on. So those are counting numbers or natural numbers. So the second one is whole number. So whole numbers consist of the natural numbers with the addition of the number 0. Now, for example, the set of whole numbers is W. We can write like this, starting from 0 to 1, 2, 3, 4, and so on. So we call this whole numbers. And the next one is integers. The sets of integers builds on the set of whole numbers by adding the negative values of each. So integers we can represent on number line like this. So you know the number line middle is 0. On the right side we can write plus values. On the left we can write negative values. Plus 1, 2, 3, 4, 5, 6. On the left we can write down now -1, -2, -3, -4, and -5. So set of negative number in so integers we can write negative values, 0, and the positive values. So set of integers we can write down as I, and then we can say -3, -2, -1, 0, and 1, 2, 3, 4, and so on. So the next one is the rational numbers. So the rational number is any number that can be written in the form of A over B, where A and B are integers and B is not equals to 0. So any numbers, if we can write A over B, where A and B are integers, as well as B is not equal to 0. So for example, we can write down 8 divided by 2. So this is a rational number, but if you write down 8 divided by 0, we can't write. This is not a rational number. Why? Because 8 divided by 0 reaching to infinity. So it's not defined. So we can't write like this. So examples of rational numbers. Any fractions or improper fractions are rational numbers. Now see that mixed number 2, 1 over 3. 3 times 2 is 6, plus 1 is 7. So 7 over 3. I can write down this one as an improper fraction. Now we have numerator and the denominator. So this is A over B, and this is a rational number. And also all integers, sort of negative 11, negative 3, and then 68, any integers, because these integers we can write down. Negative 11 we can write as negative 11 over 1, or we can multiply both numerator and denominator by 2. We can write down as negative 22 over 2. So all are rational numbers. All integers are rational numbers. And also all terminating and repeating decimals, both positive and negative, are rational numbers. Now for example, 0.8 is a rational number, because 0.8 you can write as 0.8 you can multiply by 10. You know, the denominator is 1. The same side you multiply by 10, and then on the top you have 8, and the bottom you got 10, and then you can simplify further. You have 4 over 5. So this is a rational number. And also 1 over 3 is a rational number. Why? Because see, when you divide 1 divided by 3, and how many 3's goes inside 1 is 0. 3 times 0 is 0. And 1 over 0, 1 take away 0 is 1. Put 0 here, put the dot. And then how many 3's goes inside 10 is 3 and 9. 1, 0, 3, 9, 1, 0, 3, 9, and 1, 0. It continues like this. So 0.3 is a pattern, and then it's 3 is repeating over and over again. And then is this also a rational number? And then look at this example, 7.12, and then 7.12, 12, 12, 12 is never ending, is repeating. So I can write 1, 2 as like this. And so this is a rational number, right? And then for example, square root of 13. So square root of 13 is 3.605513 is so on. And look at this one, is never ending, and also it's not repeating. We can't find any patterns over here. So therefore this is not a rational number. This is irrational number. Similarly, square root of number 2, square root of 2, square root of 2, also not a rational number. It is irrational number. So this one, 1.41412113. So it's, you can't see any pattern over here, right? And then also never ending. And then this is a irrational number, 2.333. Is this a rational number or irrational number? This is 2.3333 is repeating the same number. So we can write as 2.3. It's continuous like this, and then this is a rational number. And also 5.0100382. So this is never ending and also is not repeating. So this is an irrational number. Irrational number. The value of E also irrational number. Right? Value of phi also irrational number. Okay, let me summarize what we learn over here. So we have all the numbers we call real numbers. And then we have here rational numbers. And then also we have irrational numbers. So under rational numbers, we have integers, we have whole numbers, we have natural numbers. So I hope that you understood this lesson. We can continue from next lesson. Thank you.